Time to start setting up the battle. We have to set up the background, a default scene, and some monsters, so we can see at least something. We can also add animations while we are here, and once we have all of that, we have a pretty good start. In the next part, we are going to talk about monster resources. Those are going to control the monster itself. For now, we are basically just creating a shell. Inside of Godot, I want to create a 2D scene that I am going to rename to battle. This I want to save. Inside of scenes, there we have characters and levels. We don't need either of those. Instead, I want to create a new folder for battle. In there, I want to save battle.tscn, click on save, and then we have one scene that we want to run by default. Inside of project settings, you want to go to run, remove the current main scene, and then select scenes, battle, and battle.tscn. If I run the scene, we can see that we can't see anything. That is exactly what we wanted. Now to see something, I want to add a sprite 2D, which is going to be the BG, or the background. For which, if you go to graphics and backgrounds, you can find 3 files. One for grass, one for desert, and one for the ice background. Just pick one of them. I'm going to use the ice one. This is going to be our background, but at the moment, if I run the scene, it only covers part of the scene. But this thing needs to cover everything. I think the easiest way of achieving that is to add a camera to the scene as a child of the BG node. Once you're doing that and you zoom out a bit, you can see the camera outline. This is what we actually want to show. Although, this we have to zoom in just a bit more. And I think in my case, a zoom level of 2 captures this background perfectly. Which means, if I now run the scene again, we can only see the background. After that, we need to make space for the actual monsters. For those, I want to add a node 2D. That is going to be the start positions, in which we have a child node 2D for the player and another one, so duplicate it, for the enemy. Inside of these nodes, I want to add a marker 2D for each start position. If you drag the marker 2D for the player, they should be on the left side. The top one you want to have up here. The second one you want to have roughly in the front. And the third one you want to have in the bottom. When we have actual graphics, you can readjust this. For now, I just want to have a basic outline. The same thing I want to do for the enemies, which means a marker 2D, where the first one goes roughly on top, the second one goes here-ish, and the third one goes to the bottom, like so. That way we can control where a monster is going to start. All of this should be collapsed, because finally, I want to create another node 2D for the actual monsters. Although those inside of the game, I am calling battle sprites. And once again, we're going to have the player monster sprites and the enemy monster sprites. Which means I want to have 2 node 2Ds for the parents, one for the player, and another for the enemy. And that is all the nodes that we have to create for now. We have a background with a camera, and this, by the way, should be locked so we don't move it accidentally. Then we have the start positions for the player and for the enemy, all of which are marker 2Ds. Finally, we have another node 2D for the battle sprites, and in there we have the player and the enemy. Your scene tree should look like this. Once we have that, we can create the actual monster. Although, to be a bit more specific, we are not creating the monster itself. Instead, we're going to display the class that will display the monster data. The stats themselves are going to be managed by a resource. I'll talk about that in the next part. I want to create another scene where the root node is going to be a sprite 2D, which I want to rename to battle sprite. Save the scene inside of the same folder, and then let me zoom in quite a bit. Then I want to go to graphics and battle sprites, in which you can find all of the graphics for every single monster. Just pick one of them, it doesn't matter which one you start with. I want to go with Sparchu, like so. This is going to give you 8 images. The top row is the idle animation, the bottom row is the attack animation. We are going to manage all of that via an animation player. But first of all, for the animation inside of the Sprite 2D, I have 4 H frames and 2 V frames. To animate the entire thing, I am going to update the frame itself with an animation player. Add this one, animation layer, where we have 2 animations, an idle one and an attack one. For the idle animation, I want to target the property of the sprite and specifically the frame. Essentially in here, I want to add the 4 frames for the idle animation. Insert a key. The first value should be 0. The second value should be 1. The third value should be 2. And the final value should be 3. And I'm spacing them 0.2 seconds apart, like so, with the entire duration of the animation being 0.8 seconds. This one should loop and autoplay. If I now run it, you can see the idle animation. Attack is going to work in pretty much the same way. I want to get a property track of battle sprite and frame, where we are getting frame number 4, 5, 6, and finally 7, and space them 0.2 seconds apart. Once again, the duration of this animation should be 0.8 seconds, or whatever length you think feels good. This is going to give us the attack animation, and I think that looks pretty alright. Once we have that, inside of the battle scene, once the battle starts, I want to create 6 monsters, 1 for each start position. Which means, to battle, I want to add a script. The defaults are fine, and I want to run something once the scene is ready. So func ready. Now to organize the logic, I have written a couple of functions. The first one is going to be the battle sprite setup, in which I want to have the start positions, the parent nodes, and if we are the player or not. This we want to do for the player monsters and for the enemy monsters. For the enemy monsters, the final argument is going to be false. This is for the player, and this is for the enemy. Now to create that function, I want to have battle sprite setup, in which we are getting the start positions. This is going to be a node 2D. Then we are going to get the parent, also a node 2D. And finally, we have is_player, which will be a Boolean. Here is the entire line for start position and parent. You want to look at the scene tree. For example, if we're setting up the player monsters, I want to get for the start position, start positions, and the player. Like so. In there, we're going to look at all of the markers. The same thing I want to do for the enemy. We're going to get enemy inside of start positions. For the parent, we are going to do pretty much the same thing, except now we are looking at the battle sprites. The parent for the player monsters are going to be battle sprites and player, like so. For the enemies, it's going to be battle sprites and enemy. And then, when we are working inside of battle sprite setup, I want to go for, let's call it start position in start positions.getChildren. Or to be a bit more specific, this could be the start position marker, which has to be a data type marker 2D, from which we can get a position. So var position is going to be the start position marker dot position, which I want to print. Print position, and then if I run the scene, these are our start positions. And this we can use inside of another function, create battle sprite. Inside of this function, we create the actual battle sprite, for which we will need a position, the parent, and for now, if the monster is a player monster or not. This function doesn't exist, so func create battle sprite, where we have a position, which is going to be a vector 2. We have a parent, this is going to be a node 2D. IsPlayer is going to be a Boolean value. And inside of this function, I want to create a var battle underscore sprite, for which I want to get one instance of the battle sprite scene, which means we have to preload it. Var battle sprite scene is going to be preload battle sprite.tscn. Inside of create battle sprite, you can get the battle sprite scene and instantiate it. After you have done that, you can get the parent and add child battle sprite, which should mean that we are getting something inside of the game. The reason why we are only getting one monster is because we are spawning all 6 of them in the same position. To fix that, I want to get battle sprite and call a setup function, which at the moment is getting the position and is underscore player. This function we have to create inside of battle sprite. I want to create a script. The defaults are fine. All I want to create is func setup. For now, with 2 parameters, a position, which is a vector 2, and is underscore player, a Boolean. And then for now, I simply want to set the position to what we are getting from the pos parameter. That way we should be seeing 6 monsters inside of the game, and we do, but the monsters for the player should be flipped on the horizontal axis. That way the monsters are looking at each other. That we can achieve quite easily. I want to have flip h of the sprite, and this is going to be is underscore player. And with that, we are getting the monsters facing each other. That's a really good start. Time to talk about the monster data. This will be the actual monster. It itself is not going to be visible inside of the game. For that, we are going to use the battle sprite. So effectively for this part, we are just going to create data and keep track of it. That means for each monster, we have to track a couple of variables. Most importantly, we need health and energy. We have to know the level of the monster and what attacks are being unlocked. Remember, inside of Godot, for each monster, inside of monster data, we have an attacks dictionary where, for example, level 0 unlocks the claw attack. On level 12, we're getting fire, and so on. This we have to manage. Ideally, we also want to have easy access to the monster data dictionary. Once again, monster data is this big dictionary, and in there we have all of the monsters. For each individual monster, I want to, for example, know what the maximum HP are for that monster, or what the elements are, or what the icon texture is, things like that. For all of that, we can use a resource, which is an inbuilt feature in Godot. But fundamentally, it's just a data container. And even more fundamentally, it's basically a script that is not attached to a node. That's all that the resource really is. It will not be part of the scene tree because it's not attached to a node. But you do get the normal GDScript features, like export, variables, functions, all of that. This kind of data structure is ideal to track our monster data. Every single monster is going to be one resource. Let's create that. If you look at the file system, I want to create a new folder for resources. If you right-click on that folder, you can create new, and you might be tempted to create a new resource. But that's not actually what we want to do. We want to create a script, and this is going to make sense in just a second. For now, just follow along. For this new script, we want to inherit a resource. And if you spell this correctly, this is also going to work. Now Godot is happy. Then we need a name. I am going to call this the monster underscore res, short for resource. All of this you want to save. After which, you have the monster resource.gd file, which is just another script file. The only difference now is that this one is extending a resource. The only line we have in here is that we are extending a resource. This file is going to become the blueprint for the resources. You can right-click on resources again, create new, and click on resource. Godot wants to have a node that it inherits from. That way we have some basic data to work with. All of these are just basic data types. For example, there we have a circle shape, or we have an animation library. All of these are basic resources that just store data. And in our case, we want to store monster data, the resource we have just created, which at the moment is not available. If I look for monster resource, it does not exist. That is because for this file, we need a class name. Just add class name with the name that you want. In my case, monster resource. If you now save the file, you can right-click on resources, create new, resource, and if you now type monster, you are getting monster resource, the file that we have just created. Let's do that. And then Godot wants to have a name. Let's call this one test. Now we have a test.trace file that on its own doesn't do anything. If you look at the inspector, we get pretty much nothing. That being said, inside of the script, we can, for example, export var. I call this one DID. The data type for this is going to be data.monster. With that, I have test.trace selected, and now in the inspector, we are getting the monster ID, which is the enum for every single monster. If you look at data.gd, the enum we are currently using is this monster, which contains all of the monsters available inside of the game. And via export, we can select one of them. Besides that, another thing I want to export is the level, which is just going to be an integer. If I save this for test.trace, we can now select a monster and a level. Let's say 10. This kind of resource we can then use inside of the battle sprite. An easy way to use that is to simply export the resource, which needs to be a variable with the data type monster resource. Once you have that, inside of the inspector, you can drag and drop test.trace in there. After which, once the scene is ready, func_ready, I can, for example, print the resource.id or level. Let's print both actually. ID and level, and if I now run this, every single monster is going to get 0 for the enum and 10 for the level. As a reminder, for enums, inside of data, the first value is going to be 0, the second one 1, then we get 2, 3, 4, and so on. Enums are basically just integers with a fancy name. And this is what we are printing. That being said, now that we have an ID, we can use that to access the battle texture. If you look at data and the monster data, the main key is going to be the monster enum, which we are storing as ID inside of the monster resource, this value. From monster, we can go to battle texture and then load this one texture. That one is actually quite easy. Inside of battle sprite, I want to get the texture of the sprite 2D, this sprite here. Then I want to get data, the monster data, in which we need the key, which at the moment we're getting from the resource.id. And then in there, we have the battle texture. This would return the string to the file that we actually want to load for the monster. Keep in mind though, this is just a string. To turn it into a texture that we can use, we have to load it. And with that, if I run this, we are not going to see a difference because we are using the default monster in both cases. However, if I now double click on the test resource, I can change the monster to literally any other. Let's go with Aatrox, and now If I run this, we have loaded a different monster. This is going to work for all of them. Just pick whatever you like. You always get some kind of data. And that fundamentally is the way you are going to use resources. Later on, inside of the monster resource, we're going to add a lot more data and quite a few functions. That way, we can store the data and access the dictionaries inside of data.gd very easily. That being said, for now, inside of data, I want to have two more variables. The player underscore monsters, which is going to be an array, and I want to have the enemy monsters as well, like so. Inside of these arrays, we are going to need the resource as well, because at the moment, we are assigning the same resource to every single battle sprite. And obviously, that isn't ideal. This should be more flexible. For that, I have these two arrays, which should have instances of the resource, which I can create via another function. New monster resource, where we have two parameters, an ID and a level. To create a new monster resource, you simply want to do the usual. So a name for the variable, monster resource, and then monster resource.new. That way you are getting a resource on which you can call any kind of function. I want to create a setup function where we pass in the ID and the level, after which we want to return that monster resource. This we can then use inside of these arrays to get some basic data. For example, in the player, I can create a new monster resource with, let's say, monster.sparchu and level 20, which I want to duplicate twice. So we have 3 monsters. Aatrox and Jakana would be 2 other monsters, but you can pick any of them. Also, to get different levels, let's choose a different number. All of this I want to duplicate, so we get enemy monsters as well. That is going to return data for every single monster, which I want to use when I am setting up the battle sprites inside of this function, or rather inside of all of these functions. When I am calling the battle sprite setup function, I want to have one more parameter, which is going to be the data. It is a simple array that we have just created. For the player, this is going to be data.playerMonsters. Data.playerMonsters. For the enemy, this is going to be data.enemyMonsters. That way, we are getting the resources. This data we now have to use, and for that, unfortunately, we have to rewrite this for loop just a tiny bit. At the moment, we're getting 3 start positions, 1 for each marker, but it is entirely possible that inside of enemy monsters, we are only getting 2 monsters. That we have to account for. The way I have approached that is, I want to have a start position index, which has to be an integer. And then I get start positions, get children is going to be replaced with get child count. That way we get 0, 1, and 2. 1 for each marker. That part is still working just fine. I want to check if the start position index is smaller than data.size. We only want to do something if we have the data available for it. In there, I now have to get the position, which I can get from the start positions along with get child and the start position index. That way we are getting the marker 2D with the position again. That way all of this should still work just fine. Now besides the position, we also want to get the monster resource. This has to be a monster resource, and the value is simply going to be data and then the start position index. Effectively via that, we're getting the first 3 resources from the array, which we are then going to pass into create battle sprite. So in there, monster resource. Next up then, inside of create battle sprite, I want to have a resource which needs to be a monster resource. which we are then in turn passing into the battle sprite setup function. Resource. Nearly done. Inside of the battle sprite, I don't want to do any of this. The resource should only come from the setup function. I want to have a resource, monster, resource, which I want to store first of all inside of a variable. Let's call it monster underscore resource with the enforced data type. And in the setup function, monster resource is going to be the resource, which for now I simply want to print. We have done a ton of stuff. Let's see if it works. If I now run the script, we are getting an error because inside of monster resource, there's no setup function. That doesn't make sense. Inside of monster resource, I want to have func setup, where we are getting a new ID and a new level. The ID is going to be the new ID and same for the level. Level, new level. If I now retry all of this, we are getting 6 resources, 1 for each monster, which we can see inside of the battle sprite setup function. This resource is now containing the monster ID and the monster level. As a consequence, we can once again use it to load the right texture for the sprite 2D. We have done this before. We want to get data, monster data. Now we want to get the resource.id, and on there we have battle texture. This is a path that we want to load, and then we should be getting different kinds of monster. That works really well. On top of that, inside of data, I could change any of these to, let's say, Cinderil or Volkio. And let's say for the player monster, we are getting Gulfin is another one. If I try all of this, we're getting different monsters. Looks pretty good. Now that we have the basic setup, we can work on the battle system. For that, we need to make the game interactive. Number 1, each monster is going to get UI elements. That way we are showing name, level, readiness, health, and energy. On top of that, we will need a battle menu so that the player can select different options. Both of these parts are going to be quite extensive. So before we get to them, I want to do a couple of minor parts. Back inside of Godot. First of all, I want to have different backgrounds. At the moment, we always have the same BG for the grass. However, inside of graphics and backgrounds, I want to control what kind of background we are getting. For that, inside of data, we do have a biome enum that we want to use. And I think the most efficient way of doing that is to create another const dictionary. I call this one the biome BG, which is going to be a dictionary where we, for example, have biome.grass. The associated value is going to be background 1. This I want to duplicate twice and then get desert and ice. For those, we're getting background 2 and 3. And now we have associated our biome with a couple of files, which means inside of battle.gd, let me minimize everything. Before we are setting up the sprites, I want to get the sprite 2D called BG and update the texture. The file I want to access is inside of data. There we have biome BG. And as a key, I want to have also from data a current underscore biome, which does not exist at the moment. That we can fix easily. Inside of the variables, I want to have a var current biome. The data type for this always has to be biome, and we can set a default value. Let's say biome.grass. That way, by default, nothing should change. Let's try. And we are getting an error because this is returning a path that we are currently not loading. To fix that, you want to have load and then the same thing. Now this works again. Perfect. And if we're changing grass to, let's say, desert, then we should be getting the desert background. Perfect. That works. I guess beach might be a better name here, but you get the idea. Now we can customize the background. In part 3, we're going to set this value dynamically, depending on where the player is in the overworld. But that's not an issue for now. Instead, when I'm running the game, I think this window is just a bit small. To fix that, inside of Project Settings, under Window, let's go with 1920 by 1080. That should give us more space, although for that to work, we have to adjust the camera. Now, instead of zooming in 2 times, we want to zoom in 3 times. The outline of the camera should align with the border of the sprite. That feels a lot better. Now we can work on the UI of every single monster. And I think while we're at it, we do want to make sure that we have a broad range of monsters. So for player monsters and enemy monsters, we want to have a broad range of monsters. So different colors, sizes, stuff like that. For example, for the enemy monster, all of these I think are fire monsters. Let's change one of those to pouch. That's a plant type. And I think the others are pretty okay. Let's also go with different levels, so we get a bit more variety. That's going to become important later. But this part isn't that important. If I now try this again, we are still getting a decent result, so this looks alright. With that, inside of the battle sprite, we have to start creating the UI for the monster. For that, I want to attach a control node to the sprite, which at the moment looks a bit weird, so you want to make sure that this is centered. That looks a lot cleaner. Now we have to deal with one important issue. We have a control node as a child of a node 2D. The best way to combine them is, inside of the control node, you want to set a custom minimum size. In my case, 80 and 120. On top of that, you want to make sure that these needles are centered around the center. That way, this object doesn't scale with the window resolution. We effectively turned it into an area with a size of 80 by 120, and this doesn't change, which is all we need. But inside of this space, we can add control nodes. We can add a panel container that is going to display the monster name. I call this one the name container. This container should be in the center top, like so. And then inside of layout, I want to have a custom layout. The anchor points can stay as they are. And for the anchor offsets, all of these values can become 0. We don't really care about them. The text should set the size. Speaking of which, I want to add a margin container, and as a child of that, I want to add a label. Inside of that label, we're getting the monster name. For that monster name, I want to have some margins via the margin container, theme override, constants. I want to have 4, 2, 4, and 2. We can work on the proper styling later. For now, I just want to make sure that this is reasonably working. And that looks alright. This name we can change right away. Inside of the script for the battle sprite, we are currently updating the texture. Besides that, I also want to do a UI setup function. We are going to do a bit more stuff on the UI later, so all of this could be organized via a function. UI setup, in which I want to get the label and set the text inside of it. The value for this is going to be what we're getting from data, and the monster resource.id. Monster resource and ID is going to give us the monster enum. Via data and monster data, let me open it, we are getting all of this. In there, we have the actual name for the monster, which means from this return dictionary, we want to get the name, which should be working. And it does. That looks good. We're getting all of the names. That covers the name container. Next up, I want to add a texture progress bar. This one is going to be on the left side. Inside of the inspector, for the fill mode, I want to go bottom to top. And for the textures, you want to look at graphics, UI, and there we have vbar.png. This I want to use for under and for progress. We are going to use it twice. To make this work, we want to tint both of them. The color for under is going to be 1F, 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 a really, really dark gray. And the color for progress is going to be FF, FF, 6A, which is a yellowish color. Once you have that, and let me zoom in just a bit, I can increase the value, and we're getting a pretty nice effect. Although for the proper formatting, you want to minimize all of this so we have more space, and then go to layout and have a custom layout. I don't want to have any of these offsets. That way we are right in the center of the left side. Let's see how that is looking. And that works pretty well. Now this texture progress bar, we should rename this. We are going to track if the monster is ready or not. Let's call it ready progress bar. And to use it, inside of the code, I want to use the func, let's do it all the way at the top, func_process. Effectively, I want to do if the monster is not paused, which is a variable that doesn't currently exist. So let's create it. Var paused is going to be a Boolean with the default value of false. If that is the case, then I want to get the ready progress bar like so and increase the value. To that, I want to add a small value. For now, let's say 20 times delta. That might be large enough to get something. Yep, all of the monsters become ready. Now obviously, we want to have something flexible that is being set by the speed of the monster. Inside of data and the stats, we have a speed value. This we want to use. That's going to be the next part.